this is an iHeart podcast. Guaranteed human.
The springtime thaw is finally here. Flowers are blooming, days are longer. We're saying yes to more plans and finally getting outside, running, walking, just moving again. It's the perfect time to upgrade your everyday go-tos with Bombas. Take Bombas sport socks. They're super comfortable and designed with sport-specific tech for running, cycling, yoga, hiking, you name it. I use them to run in, and I can tell you they work beautifully. So head over to Bombas.com and use code SYSK for 20% off your first purchase. That's BOMBAS.com, code SYSK at checkout.
All cat parents understand the feeling of being totally ignored by your cat and often thinking, does my cat even love me? There's only one solution to solve that, Sheba. Feed your cat Sheba and go from feeling ignored to truly adored in 12 days guaranteed or your money back. Sheba has a menu of products, appetizers, entrees, treats, and even a kittens menu. So Sheba has a product for even the pickiest eater, like Sheba Puree made with bone broth, a smooth and creamy texture that cats love, or Sheba Grilled, protein-rich formula made with real chicken and seafood. To learn more, check out Sheba.com.
Hey everybody, it's Josh and Chuck, your friends, and we are here to tell you about our upcoming book that's coming out this fall, the first ever Stuff You Should Know book, Chuck.
That's right. What's the super cool title we came up with?
It's Stuff You Should Know, an incomplete compendium of mostly interesting things.
That's right. And it's coming along so great. We're super excited, you guys. The illustrations are amazing, and just the look of the book, it's exactly what we hoped it would be, and we cannot wait for you to get your hands on it.
Yes, we can. And you don't have to wait, actually. Well, you do have to wait, but you don't have to wait to order. You can go pre-order the book right now, everywhere you get books, and you will eventually get a special gift for pre-ordering, which we're working on right now.
That's right. So check it out soon, coming this fall.
Welcome to Stuff You Should Know, a production of iHeartRadio's How Stuff Works.
Hey, and welcome to the podcast. I'm Josh Clark, and there's Charles W. Chuck Bryan over there. And this is Stuff You Should Know, the Dirty Dirt edition. That was the best I could come up with, and I even had days to think of that, and that was it, Chuck. I'm sorry.
Yeah, this is a cool one. You know, we're into gardening, so it's always nice to talk earth biology.
Yes, agreed. And I had I thought a decent idea about this, but boy, did this article open my eyes.
Yeah, and this, we covered sand, and we covered compost.
Permaculture,
we sort of danced around soil. We've danced in soil.
Yeah, our toes are all dirty.
But, this is good to finally check this one off the old list.
Agreed. So people are probably like, I don't know about this one. I would hope that it's been, long enough, we've been at it long enough to just trust us, that if it sounds boring, we're going to find something interesting in it. And I dare say that is going to be the case with this one too, Chuck.
Well, I hope so.
So to understand soil, we have to understand what soil is, where it comes from. And soil is basically just worn down rock, just like sand is, right? I think we talked about in our Are We Running Out of Sand episode that rocks get weathered and kind of taken downstream all the way to the sea, and they get gently broken down over time into this very nice little beach sand and washed up on shore, and that's where sand comes from. Well, basically, that is also part of the same process for producing dirt as well. It's just weathered rock that's broken down into different sizes that basically make up different types of soil. That's the main structure of it is basically just weathered rock of various sizes.
Yeah, so you can, wind can do that over time. Water, and obviously the combination of all these is where you really get your money's worth.
Sure.
So you've got your wind, you've got your water. When you get weather going on in your seasons, you get the freeze-thaw cycle, which is a really kind of speedier way once that water gets in those little tiny fractures in the rock and freezes and unfreezes and cracks. That'll really speed things up. And then you get a little help from our little tiny critters under our feet.
Yeah, tiny critters of all shapes and sizes, from like microbes like bacteria and fungi all the way up to like prairie dogs and gophers. They're basically taking all this stuff and mixing it together. But the stuff that they're mixing together is, so you've got the structure of the soil from broken down rocks, but that's just one big component. You have to have life living among it, or else it's not going to do anything. It's just dead. There's nothing to it. So part of the process of forming soil is taking those little gritty pieces of weathered rock and adding decomposing organic matter to them. And that's where we finally start to get to what we understand as soil.
Yeah, because once you have that, it can hold a little bit of moisture, and then that means little plants can grow. Those little plants grow. They eventually die. It's very sad for the plant and the plant's family, but it happens to all of us. And then those little plants that die, they decompose, and they're holding all that carbon dioxide in their little skinny stems and leaves and body. And that carbon dioxide stays behind, and it's dissolved by water, and then that forms carbonic acid, which isn't, if you want to throw a body in a barrel, you don't want to use carbonic acid.
No, you're going to get caught still.
You're going to get caught. So it's not super strong, but it is strong enough to help break down all those little rocks and everything even more. And before you know it, you've got soil, baby.
Yeah, you got soil. So all that decomposing organic matter is full of like nutrients that kept the thing alive while it was living. And then all those little tiny animals and microbes that eat that stuff break it down even further, which unlocks all of the nutrients within. And that means that plants can start to take them up in its roots and use those nutrients to grow. And so that's a big part of what soil is. It's like a nice little substrate, a medium for holding nutrients. And then the whole thing is actually held together itself even further by the roots that the plants that grow in the soil spread out and stabilize too. So I think one of the things, we've just hit upon one of the reasons I love soil so much. It's harmonious and symbiotic. Like everything living in the soil almost is involved in keeping everything else going and alive. It's like part of a really beautiful, complete system.
Yeah, and that's why, we always make a big deal, and science makes a big deal out of the disruption of this, and not just this process, but all Earth processes.
Yeah.
One little tiny thing will lead to another little tiny thing, and before you know it, you got issues on your hands.
Yeah, you do for sure. You can't let it get out of whack. Luckily, from what I found, I started to get into like lawn care and stuff like that. It's my new thing.
Would happen at some point.
And
you made fun of me years ago, and I was like, "You just wait."
Yeah, it's true. It's true. And I've learned not to flood my lawn with a 1/4 inch of water. But the best fertilizer and aeration that I found is just basically feeding microbes to your lawn. Like you don't need to like go dig holes and core plugs in your lawn. Just if you add the right kind of microbes to your lawn, all of that will just kind of turn it into this healthy soil beneath it on its own, which I just love because it's just spraying microbes onto the ground. What's more beautiful than that?
Well, we've gone the opposite. We have zero grass now, basically.
Oh, I know. You just love to rub my face in that, but still.
No, it just kept going more and more, and it got smaller and smaller, to the point where I was like, why am I holding on to this tiny little patch of grass?
Why do I even have a weed whacker at this point?
I know. I haven't used a weed whacker in 2 years. It's great.
That's awesome. I got a big old honking gas-powered lawnmower even too, so I'm basically going the exact opposite direction as you.
Do you have a rider now?
No. It's not that big. It's not that big. No, yeah, it's a rider. It runs on like the tier of baby deer.
That's what John Deere means.
Yeah.
So if you're talking soil, you need to talk soil horizons. And, we'll get to sort of the list of the different horizons here in a few minutes. But soil horizons are these horizontal levels, these striations that, if you look at, like, if you go to any science center, they'll probably have some kind of cool piece of glass with a frame and you have soil in there and they have little lines drawn
Yeah.
to mark these different soil horizons, because soil is not all the same from the very top of the topsoil down 3 feet. It gets very different, and you want space in there. You want air in there. You want to have water to be able to travel through there.
Right.
I think they say if you want like really good soil, should be about 50%, just 50% soil, and then 50% just space for air and water.
Yeah, exactly. And then you want about half of those spaces to be filled with water. So you got about 50% soil, 25% air pockets, 25% water-filled pores. That's ideal for sure. And that's And the reason, the way that you get those pores and those pockets and everything is because there's different types of soil, there's different shapes of soil, and there's different sizes of soil. Like we said, there's sand, but there's also silt, and there's also, and get ready for your socks to be not clean off of your feet, there's also clay, which clay, whenever I think of clay, it's like a big hunk of something that I'm like having to dig through to plant a plant, and it's enormous. But it turns out that clay is actually the finest, smallest type of soil, and it's so fine that it compacts together into these large aggregate pieces of clay that we think of when we think of clay. But that's actually huge, enormous chunks of extraordinarily tiny pieces of dirt, of soil, that are so small you can only see them with an electron microscope if you want to look at them individually.
Yeah, and clay is important. It's all part of the mix that we'll talk about here in a minute. But, if you start off with just a barren rock landscape, there's a very smart lady. Who did this one? Was this
I think the Grabster helped us out with this.
Was this the Grabster?
Yeah.
He must have interviewed Dr. Caitlin Hicks Priest, who's an assistant professor of biological sciences at Dartmouth.
Yeah.
And she said, if you start off, we've seen it happen. If you start off with just bedrock, in about 100 years, you could probably grow a tree there in the soil that you would get.
Seen it happen a million times.
100 years, that's all you need.
Right. And the reason why it can happen so fast is because some plants are early colonizers, and they can grow in just a little bit of, soil, just a little bit of fine rock. And as long as there's like nutrients and water coming to it, it's fine. It doesn't need a big thing of like topsoil or potting soil. It can make do like that. And then once those plants start to die, they start to decompose, and then it really kicks off. So yeah, you can have like soil, a couple of horizons of soil in 100 years if you're really boogieing.
All right, should we boogie on down and take a break?
Yeah, let's
get our hands dirty, and we'll come back and we'll talk about these horizons right after this. Hey everybody, we want to talk to you about The Big Bang Theory. That's a show that became one of the most defining sitcom of its era and really built a fan base around its memorable characters and unique group dynamic.
That's right, which is why we think you'll enjoy the official Big Bang Theory podcast. It's back, covering seasons 3 and 4 of the show. Host Jessica Radloff sits down with crew and cast members like Kunal Nair, who plays Raj, Mayim Bialik, who plays Amy, and Kevin Sussman, who plays Stuart.
That's right. You're going to learn all about the Easter eggs you may have missed, behind-the-scenes stories, and how certain real-life relationships shaped some of the most memorable storylines.
Yeah, there's cast reflections years after the series aired and expanded content around famous episodes and storylines. It is exactly what you're looking for if you're a fan of The Big Bang Theory. The season is on video, so watch the official Big Bang Theory podcast on HBO Max, or listen wherever you get your podcasts, and stream episodes of The Big Bang Theory on HBO Max. The springtime thaw is finally here. Flowers are blooming, days are longer. We're saying yes to more plans and finally getting outside, running, walking, just moving again. It's the perfect time to upgrade your everyday go-tos with Bombas. Take Bombas Sport Socks. They're super comfortable and designed with sport-specific tech for running, cycling, yoga, hiking, you name it. I use them to run in, and I can tell you they work beautifully. So head over to bombas.com and use code SYSK for 20% off your first purchase. That's BOMBAS.com, code SYSK at checkout. Okay, Chuck, horizons. And speaking of horizons, I think there was a Disney World ride or an Epcot Center ride called Horizons or something like that. And there was this group of people who infiltrated it. They figured out how to get basically behind the scenes and would hang out there for like entire weekends and like hide during the regular hours and then just hang out like they were part of the set after hours. After
Was
the
it about
park
soil?
closed. No, it was about future life, like what life was going to be like in the future. It was really cool.
Oh, sure.
But the upshot of all this is that they documented the whole thing with pictures, and it's somewhere on
cool.
the internet. I can't remember where, but I'm pretty sure it was called Horizons. But it's a closed-down Epcot ride where a bunch of people documented it in the early 90s just with cool pictures of it. So check it out.
And that's probably why they closed it down.
I don't remember why they closed it down or what it became, but I think it's not nearly as cool. I never got to ride it, but seeing those pictures made me wish I'd been able to go.
So here are a bunch of the horizons. If you're talking about pedology, which is the study of soil, it's a bit of an unfortunate name.
Sure.
But we're going to talk about horizons, not the event horizon, not the gateway to hell itself.
No, the chaos and disorder of unparalleled horribleness.
Did you see that?
Loved it, yeah.
Yeah, it was pretty good, huh?
Yeah, when's the last time you saw it?
When it came out. I don't think I ever repeated that one.
I saw it in the last couple of years, and it holds up.
Not
I've seen
bad.
it several times since it came out, and it's a really genuinely good horror movie.
Yeah, I agree.
I also saw Solaris, too, recently, and that's a really great movie, too.
The Russian version or the
No,
Clooney?
I've still never seen the Russian version. I've seen the Soderbergh version.
Yeah, it was good. I would recommend the Tarkovsky. It's a bit of a grind, but
Worth it?
sure. His movies are all worth it, but they're just, they're tough. If you're sleepy, don't try it.
Okay. It's like The Irishman, but Russian and in space.
And good.
Okay.
So the O horizon, these are some of the different horizons. The O horizon is that like not even topsoil yet. It's the leaves that blow off of trees and are sitting sort of on top.
Yeah.
That counts as the O horizon.
They're basically the things that are in the initial state of decomposition, not right on top of the dirt.
Yeah, exactly.
Underneath that, then, is the A horizon. So this makes 0 sense already because we went from O to A.
Yeah, none of this makes sense.
The A horizon is what we would consider like topsoil. It has most of the organic matter that's really begun to decompose and break down into smaller and smaller bits. And it's usually kind of dark in color. This is where the highest concentration of minerals are. And this is also where you're going to find the roots of plants, too, because they really like those minerals and nutrients.
Yeah, and by the way, when I said this makes no sense, I'm sure an earth scientist is going to say, guys, it makes perfect sense.
Yeah.
And here's why. You have the E horizon next, which stands for alluviated horizon. Mm-hmm. And that's where you've got this water draining down and those minerals that you were talking about in the A horizon. It's leaching those minerals and all that stuff out. And you've got sort of this light-colored soil in its wake.
Right. That is not a common, or I shouldn't say common. You're not going to find that in every soil sample that you take.
Right.
It's usually a product of, say, like a patch on like a hilltop where it's like the dirt's in place, but all the nutrients have been leached out over time. So anytime you just dig with the shovel into some dirt, you're not necessarily going to find an E horizon.
Yeah, and we should say that for all this stuff, it's all going to vary according to where you are and what kind of rain and flooding and drainage that you have and stuff like that.
Mm-hmm. What's next, Chuck?
You got the B horizon. That's the subsoil. And this is where you finally get down to some of the finer particles, and you've got like a lot of silt, a lot of clay. You're starting to get down to the good stuff at this point.
And all this makes sense, too, if you think about it. Like when rainwater trickles down through the soil and percolates, it's far easier for it to bring with it smaller and smaller particles.
Yeah.
So the further it travels, the smaller the particles you're going to find going down with it. So you've got your bigger particles, your looser, coarser bigger topsoil. Then you've got the subsoil, which is a little tighter together. And then in the B horizon, in the subsoil, you've got compacted. That's where you're going to hit like your clay layer. Because again, clay's made up of those tiniest little particles that have been brought all the way down as far as it can go with the water that's percolated.
That's right. And it's much more stable than topsoil as well.
For sure. Sometimes it's too stable and like water and roots can't really penetrate it.
Yes, or shovels.
It can be
Georgia.
It can be a problem child as far as soil horizons go.
You know my story when I was trying to dig my fence post holes for my privacy fence years ago was I rented a two-man auger, a two-person auger, and it just spun. It compacted the clay even more. It did not break it up at all. It spun it like a potter's wheel.
Nice. Did you go, give me some clay? Oh, wait.
It was bad.
Did you get it? That was a pottery joke, but it tied into your problem. That was maybe the smartest joke I've ever made in my life.
Oh, well, no wonder I didn't get it.
Yeah.
And I think I mentioned this on the show before. If you do have that kind of problem, if you're going to plant and you have really tough clay that you're trying to get through, or rock for that matter, get a San Angelo tool, which is that big, heavy spike that you see at the hardware store that's 6 feet long, has a pointy end on one side and a flat head on the other, and weighs like 20 pounds or something.
Yeah, I never knew what they were called. They look like sharp, pointy lightning rods, basically, right?
Yeah, I mean, it's backbreaking, but if you foist that thing into the ground as hard as you can and just wiggle it back and forth a million times,
and then you're going to
be able to. Well, you're going to be able to break up anything, basically.
And then you hit it with the auger or post hole diggers?
No, I mean, the auger was useless at that point. You just loosen it and use a shovel.
Did you get your money back and say, this auger's worth nothing?
No, because they would say, welcome to Georgia, bang.
Right. That's the state slogan.
And not all over Georgia, but particularly where we are, like up in the mountains and stuff, the soil is very rich and very pliable.
Yeah. Yeah, for sure.
It's good stuff.
As long as you don't hit the granite underneath.
Which can happen.
Yeah, as a matter of fact, because those pieces of granite that you hit as you get closer and closer to the Appalachians further north in Georgia, that's bedrock. That's like the outermost rock of the Earth's crust, right? So you're actually touching the Earth. It's almost like the soil that builds up on top of the bedrock is, I don't know, dander maybe? And the bedrock is really the Earth's outer skin. So you're touching the Earth's skin when you're touching bedrock, which can poke through the ground every once in a while, is what we call rock outcroppings.
Yeah, and so as far as the horizon levels go, just above the bedrock, I don't think we mentioned the sea horizon. That is also rock, but that's rock that has weathered down some, but didn't quite make it to soil level weathering.
Right, because remember, some plants can come in and colonize that rock and pretty quickly start building up soil. And if that rock beneath isn't exposed to that weathering process from wind and freeze thaw and all that stuff, it's never going to get broken down.
Right.
It's just going to be hard on the old auger.
And then the bedrock, and then you've got what's called hard pan. And these are mineral deposits that, I mean, this stuff, I don't know. I guess it's harder than bedrock. It just sounds like nothing will grow, and there's no chance for anything to permeate it. Yeah,
and hard pan is not under bedrock. Bedrock's as low as it gets before you, like that's the Earth's crust. Hard pan is just kind of, I think you just kind of tossed that on where it's like, this is another, it's like a E horizon, like an alluviated horizon. You're not going to find it everywhere. When you do, you'll know it because it's very hard to dig through, and there can be streaks of it within another, soil system of different horizon layers. And you just don't want anything to do with that. Neither do plants either. It's basically impermeable as far as water and roots and shovels go.
No good.
No.
Another term that I think is really just cute is parent material. And that doesn't mean whether or not you would be a good papa or a good mama to a human child. Parent material is the type of rock that you started out with, or the type of mineral that you started out with millions of years ago that was weathered down there to create what kind of soil you've got. And depending on where you live and what was there, hundreds of thousands or millions of years before you,
Yeah.
you're going to have much different kind of soil than maybe another place in the world.
Yeah, like if it started out as igneous rock from a lava flow, that's going to be different it's going to produce a different soil from, sedimentary rock that was weathered down from a granite outcropping by a river. It's just different soil. But it can also come about in different ways, like that rock outcropping that was worn down by a river and just kind of sunk further and further into the ground and was built up atop of it, soil layers were. That would be called residual, where it's developed in place. There's also transported, where it could be moved by like ice,
Right.
like a glacier pushing soil from one place to another.
Sure.
And then there's also cumulose, which is basically like peat, where organic material is basically suspended in suspended animation by water. It's prevented from full decomposition.
That's right.
Those are the kinds of parents that soil can have.
So let's talk about the soil texture triangle.
Okay.
This is where it gets pretty cool, because if you're talking soil, and I think people should start using the word soil more than dirt, because I just think it's more evocative of what you're really talking about. I think dirt is kind of reductive.
I saw a dude who is like a soil sciences professor explain that, to him at least, dirt is like dead soil. Soil is like living, breathing.
Yeah.
It's almost like it's a symbiotic organism formed by all these different other bits of life working together, whereas dirt's just like dead stuff that maybe will become soil one day.
If it behaves itself.
Right. If it plays its cards right.
So this texture triangle, if you're talking soil, is a mixture, and this is all soil, of sand, silt, and clay. Sand, it's a really good podcast episode on it. I think we did. Mm-hmm. That is the most coarse, which is funny to think about because sand seems super, super fine.
Yeah.
But when compared to silt, I think sand is 2 to 0.05 millimeters in diameter compared to silt, which is 0.05 to 0.002. And then, like you mentioned earlier, it's hard to wrap your head around, but clay is a really, really fine kind of soil.
Yeah.
0.002 millimeters in diameter, and you got to get that microscope out if you want to take a look at it.
Yeah, and because the different sizes, when they're put up against one another, if you've got a bunch of sand, the pores in between the grains of sand are going to be really big, which is why beaches don't have a lot of plant life growing on them, because water just drains right through them, and it's very difficult to keep organic matter suspended within it, right? Mm-hmm. Silt, it gets a lot easier, because from what I saw, the pores in between silt are basically ideal. They're just big enough that they drain really well, but they also can hold some water. And then clay, because the pieces are so close together, the pores between them are so small that they hold a lot of water, and they basically seal off the water's escape. So clay can either prevent water from coming in, or it can hold it in and drown things. Either way, it's not necessarily very good for roots. Super compacted clay.
Yeah, you want a nice mix, and it doesn't all have to, it depends on what you want to do and what you're working with, but it doesn't have to be the exact same mix either. I'm sure there are ideal versions, but depending on where you are, you can only do so much with your soil. Like, you can't make an entire farm something that it's not. You can augment it and help it out, but you're kind of working with what you got to a certain degree.
Yeah.
I think one of the cool things from this research was that, if you see a farmer in a movie bend down, and the scene that's in every movie about a farmer, when they grab that soil in their hand and they look at it and twist it between their fingers and then let it fall gently out of their hand onto the ground.
Yeah.
Not only does that make for a nice movie moment, but that's real deal stuff. If you're a pro farmer or a soil scientist, you can tell exactly what's going on with that soil by how it clumps in your hand, how it moves in your hand, how it holds together, what shape it is.
Right.
So it's not just a sort of a BS thing you see in movies.
No, you can also run a lab test to figure out what the ratios are, right? Yeah. Hey, college boy, you need to get yourself a farmer.
With hands.
But either way, right. But if there is an ideal combination between it, depending on what you're trying to do, for sure. You don't want it too clayey. You don't want it too sandy. You don't want it, although I don't know, I think you do kind of want everything to be kind of silty, but where they interact is going to describe what kind of dirt you're dealing with. And there are things you can do too. There's a reason for understanding that, because you can say, oh, if I add this, if I bury a bunch of grass clippings, it's going to turn this clay into more silt, and everything's going to just jump for joy from that point on.
Yeah, and if you're a home gardener, you can certainly manipulate your yard or any potted soil that you have. You can amend all that stuff till you get exactly what you need. And then once you have it in a good place, there's upkeep. But it's not like you just have to do it once, but you have to do it once really, really well, and then just sort of keep that good mix going.
Yeah, and then you can just go get one of these things that you hook onto the end of your hose and spray it once in a while with some microbes and sit back and watch everything start
Smoke
coming
your cigar.
up. Yep, that's exactly right. Made out of deer hide.
Oh, God.
It doesn't burn very well. It's kind of noxious smelling, but it really makes a point, you know?
I know we mentioned regolith in, I want to say, terraforming and other episodes. But this, sometimes people say this as a word for soil, but it's really much more than that. It's kind of like anything on top of the bedrock, basically, can be called regolith. And that's not, and we mentioned terraforming because if you talk about the moon or Mars, you talk about regolith as well, and whether or not we could grow stuff there, which apparently we could.
Right. Yeah. If we added the right nutrients and water, it would hold, which is essentially all it is at that point. It's like what that soil sciences guy was saying, that it's dirt, not soil. It's dirt because it doesn't have anything living, but you can add that stuff to it as needed and make Mars great again.
Oh, God.
So you want to talk about the carbon cycle?
Yeah. Does carbon have anything to do with the Earth?
No, it has nothing at all to do with it. But actually it has quite a bit to do with it, right? So carbon is essentially the building block for life, and there's a big cycle of carbon moving through the environment. There's a lot of it in the atmosphere in the form of CO2, and the atmosphere itself forms what's known as a carbon sink, which, if you haven't been paying attention in the last few decades, one of the reasons that climate change is happening is because we've been overwhelming that carbon sink in the atmosphere by burning fossil fuels and releasing a lot of carbon dioxide that had been sequestered in the ground, which leads us to this point that plants and soil help lock carbon in, so that in addition to the atmosphere being a carbon sink, soil is also a really major carbon sink too. Yeah,
and
you were thinking about agreeing with that or not?
No, I totally agree with it, but I mean, it's kind of like when, the Amazon rainforest caught on fire. It's almost like you're getting a double whammy there in badness.
Or like even just cutting the Amazon down to grow crops there too. Like you're creating quite a bit of harm even without burning it down, because all of those trees are really good at sequestering carbon dioxide from the air and creating a carbon sink in the ground. But then also, we'll find out later, when you till the ground, a lot of that carbon that's been trapped under there and will stay that way for 1,000 or so years is suddenly released just by tilling it. So there's basically the main point I would like everybody to take away from this entire episode, maybe our entire podcast, Chuck, is leave the rainforests alone. Just stop messing with the rainforest, because it's really screwing things up in ways that we are yet to fully realize.
Yeah. Agreed.
Okay. That was my soapbox.
That's you and Don Henley, man. Arm in arm.
Yes.
He's a big rainforest guy,
Well, we're always chatting it up about the rainforest. I got a lot of my ideas from him.
Thanks to Stuff You Should Know listener Clayton Janes, who is a guitar, well, I'm not going to say exactly what he does, but he worked on this last tour for the Eagles and invited Emily and I down before the show. I got to touch Don Henley's drum kit and Joe Walsh's guitars.
I remember you saying that. And Joe Walsh, because he happened to be standing next to his guitars at the same time.
pretty cool, man.
You were like, I'm sorry. He's like, it's okay. Life's been good to me so far. Something's wrong with me today, man. Something's bad wrong.
All right, so let's talk about carbon dioxide for a second here, because plants draw that in from the atmosphere, and then eventually they're going to break that down because photosynthesis happens, and they use that carbon to build up that plant. We're talking about the roots, the leaves, the stems. Carbon plays a big part in that. But eventually, like I said earlier, that plant's going to die, or leaves just fall from a tree or whatever, and that carbon is locked inside that leaf or that dead plant on the ground that you stepped on.
Right, exactly. So what's great about this is that plant used that carbon, and when it died with that carbon, and it was locked in, like you said, but it's able to be used by other plants that come along, which is part of that whole like beautiful system that just works so intricately well. Because to unlock that carbon, that's where all that life that lives in the soil comes along and becomes extremely important, because they break that stuff down and decompose it, depending on whether you're talking about bugs that chew up leaf litter into smaller and smaller pieces, which makes it easier for microbes to break down more quickly. The microbes themselves get eaten, and that carbon that was locked in the plant is suddenly unlocked and available in the soil for other plants to take up through their roots and build their own structures and use for photosynthesis too. It's the circle of life.
Right. Or it doesn't use it all, and some of that carbon is then released back into the atmosphere. Then we get to the humus, and I think we might have talked about this. Surely we did in composting.
Yes, we definitely did.
Maybe we did one on earthworms, right?
Yep, we talked about it in earthworms. We talked about in permaculture, I believe.
Yeah.
We may have also talked about it in desertification and droughts. Maybe.
Right. Man,
Our
we've done a lot of
droughts
good earth
episode,
science.
That was a good one.
That was good. So humus is that it's basically, if you compost something, years later, you're going to finally get down to humus. It's what's left over after all that snacking is done. And it's if you have a home composter, don't think that you have humus after a couple of months of doing a really good job composting, because it takes like many years to become humus.
Yeah, and like it's just a very small percentage of the stuff you compost will break down into humus, because apparently the precursor of humus is proteins, and most compost is made up of carbohydrates, plant materials, or carbs, right?
Yeah.
Yeah, that's right. So when it breaks down, this humus it's almost like some soil scientists apparently consider humus a third state of life, where it's not just dead, it's very dead.
Yeah.
And decomposition is not really happening anymore. But there's a lot of minerals kind of locked in there, inorganic materials. But the thing is you want humus. The more humus you have, the more lively and life-affirming your soil is. It's like eat, pray, and love down there, Because humus forms an ideal house for all that other life to live in. It's like exactly what is needed for the other organisms that make soil alive in this symbiotic network. That's what they want, is humus. And it's extraordinarily important stuff, but we don't fully understand why it doesn't necessarily keep breaking down after a point.
Yeah, it's very dark. It's like black, basically. It's very spongy. It has great water retention. It can hold 90% of its weight in water, and is sort of like the bond. It's like the cement that helps, when you clump that soil together in your hand and it stays together, you can thank humus for that.
Yeah. As a matter of fact, you should thank humus out loud when you squeeze some soil in your hand.
You totally should.
Thank you, humus. So it's like you said, like humus holds the stuff together, but it also creates those air pockets or those gaps that are so important in healthy soil, right? It keeps things from sticking too close together, yet it also keeps it in aggregations or aggregates, right? So it's really weird if you really stop and think about it. It holds things together, but not too much together. It kind of holds them together at just the right distance so that you have that ideal mixture of 50% soil, 50% gaps, and then 25% of those gaps are, can hold water moisture.
Yeah, and you've got to have that right mix because too much sand is not able to hold any water. Like you mentioned, if you go to the beach, you can just see this in action.
Yeah.
You've got to have some of that clay, though, because that's the smallest one. And it's those little micropores, it has what's called capillary action. That's adhesion and surface tension mixed together in a bag, basically.
Yeah.
And that's super, super strong. And if you have clay in your soil, it's going to hold that water, and it'll even draw water up from the water table and say, here you go out and feed.
Yeah, I saw yet another soil sciences professor talk about capillary action, and he surprised me because he showed that sand has the least amount of capillary action. There's some, how like when you're digging into the sand, right before you get to the water beneath it, it's wet. That's because the sand's still been wicking some water up through those gaps. But rather than clay being the strongest with capillary action, or the best for soil, I should say, it's actually silt. He had like 3 tubes, silt, sand, and clay all next to each other, and the silt one just rocked the other 2 for how far it had wicked water up this tube. So apparently that's the ideal. Silt is just as good as it gets, is from what I can tell.
So you're on Team Silt?
I am super Team Silt from now and forever.
All right, I think we should take another break, perhaps.
Yep.
And we'll talk about what all's living down there in that soil and what this all has to do with climate change right after this. Hey, everybody, we want to talk to you about The Big Bang Theory. That's a show that became one of the most defining sitcom of its era and really built a fan base around its memorable characters and unique group dynamic.
That's right, which is why we think you'll enjoy the official Big Bang Theory podcast. It's back, covering seasons 3 and 4 of the show. Host Jessica Radloff sits down with crew and cast members like Kunal Nair, who plays Raj, Mayim Bialik, who plays Amy, and Kevin Sussman, who plays Stuart.
That's right. You're going to learn all about the Easter eggs you may have missed, behind-the-scenes stories, and how certain real-life relationships shaped some of the most memorable storylines.
Yeah, there's cast reflections years after the series aired and expanded content around famous episodes and storylines. It is exactly what you're looking for if you're a fan of The Big Bang Theory. The season is on video, so watch the official Big Bang Theory podcast on HBO Max, or listen wherever you get your podcasts, and stream episodes of The Big Bang Theory on HBO Max.
So you're considering getting a home security system, but you want something that fits your space. Well, with ADT Blue, it's easy to customize a system that's right for you and set it up yourself. Just pick the kit and monitoring plan that makes sense for your home.
Yeah, well, let's say you're worried about package theft right off your front porch. The ADT Plus app can walk you through setting up a new doorbell camera kit. Once it's installed, ADT Pros can help you keep tabs on it 24/7, or you can manage it yourself from the ADT Plus app.
That's right. There are no long-term contracts, so you can change your monitoring plan whenever you want. The flexibility doesn't end there either. You can add to your system as you need with things like extra cameras or motion sensors.
Some life decisions are hard, but thanks to ADT Blue, you can get DIY trusted ADT home security in a snap. Head to ADT.com/BLU to build your system today. And to find out more about home protection, check out a new episode of Grown Up Stuff with security expert Joe Mazza, out now on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts.
All right. So we talked about early on things living in the soil. I know it's easy to think about little microbes and bacteria and things in soil because we know it's just rife with that stuff.
Right.
But you can't ignore the big things too. There are little moles that live in the soil. There are prairie dogs. There are lizards. There are snakes. All this stuff, every like kind of larger animal disrupts the soil But that's a good word in this case. You want that soil disrupted because it's redistributing nutrients. It's, you want them peeing and pooping in that stuff and mixing all that stuff in.
Yeah.
And you've got this sort of small to larger animal system acting as little composters along the way.
Yeah, and they're actually also mechanically mixing the soil. Like, you don't want your soil to just be big, medium, small. You want it to be fairly mixed together, because big is just the gaps between are too big, and small, the gaps between are too small. You want them mixed well, and so like an earthworm burrowing actually is mixing the earth together. Gophers apparently mix together something like 1,800 cubic meters per square kilometer every year. That's a tremendous amount of soil mixing, and they're doing it for free, basically.
Yeah, and that's when they're getting along. Like, you want to really mix up some soil, you get a gopher rumble.
Sure, right.
Happening.
Yep. It
And
can
that
get
soil-
ugly, but your soil is going to be super mixed afterwards.
Oh,
for sure.
man, it's going to be fantastic.
Plus, you can roll cigars out of their hides, the hide of the loser.
Oh, boy. You've also got spiders. You've got little scorpions. You've got centipedes. You've got millipedes. You've got termites. You have roaches, unfortunately. I think right here it says in a sample of 1 square foot of 2-inch soil in the forest, 200 species of mites alone.
Yeah, pretty impressive. I've got one even better than that, right? Let's go down an order of magnitude or so.
Oh, I know where you're headed.
So the microbes in the soil are so abundant and so prevalent. Apparently, a teaspoon of soil has more microbes in it. Microbes is another pronunciation. Than there are people on Earth. In 1 teaspoon of soil, right?
That's amazing.
And all these little microbes, they're bacteria, there's viruses, there's fungi. All this microbial life are like the last layer of decomposition. But they do even a lot more than just decompose dying things. There's a function of fungus that we're just now starting to wrap our heads around called mycorrhizae, which is a symbiotic relationship. So soil itself is a symbiotic relationship. This is a symbiotic relationship within the symbiotic relationship, where fungus basically says, hey, roots, I like what you're doing there above me. I'm going to hang out around you and maybe grow my own system of roots out of fungus, me, that connects to your roots, but also goes through the ground and connects to other roots too.
It's
and
amazing.
I'm going to take up, nutrients from the soil and help you accept them into your roots, maybe bring you some water here or there. And I'm going to let you communicate with other plants through your roots, through me, to the roots of the other plant too.
So amazing.
So it's like if you look at a mycorrhizae, if you pull up like a plant, it has like this thin, almost lung-like film around it. That's the fungus. It's like a root system around the root system made up of fungus. And we're just starting to understand this. And it's just beautiful to know that it exists like that.
It's the fungus among us.
It is. And there's actually humongous fungus among us, isn't there?
Yeah. So what you were talking about is a mutualist. There are kind of 3 kinds of fungus. Mm-hmm. And I love that they call it a mutualist. It's a great name for that, the symbiotic relationship. There's
it's also
the one
a good name for like a neo-folk.
Sure.
Okay.
Yeah, why not?
Why not?
Get a tweed vest and a jaw harp and have a good time.
Okay.
I just got a jaw harp in the mail, by the way.
Is that the one that has the shoulder mounts?
No, the jaw harp is the twangy thing you put in your mouth.
Oh, gotcha.
In fact, I have it here if you want me to go get it.
I would love you to go get it. I think we'll wait.
The fungus that eats decaying matter is called a saprophyte. Then you've got your mutualist, and then you've got an actual parasitic fungus. Those are the jerks of the forest world. But you were talking about humongous fungus. I know. I feel like we've talked about this at some point.
In Pando, the Pando episode.
Was it in Pando?
Yeah.
Okay, I thought it might be. In Malheur National Forest, there is something called Genet D, and a big network of fungi is a Genet, and Genet D is the humongous fungus. It's considered the largest living individual on Earth, 2,000 acres worth.
Yeah.
Apparently, it's all connected.
Yeah, and it's the biggest by area, I think, and Pando
Right.
was the biggest by mass. Like if you weighed Pando, it would weigh more,
Totally.
but this one still covers a lot bigger area. But it's just one big single organism, and
amazing.
it's underground, and it sucks onto roots. And actually, they found it because there was a bunch of dead trees, and they're like, "What's going on here?" And they discovered that it was this one Astoya fungus that was killing off trees because it can be one of those jerk kinds, the parasitic fungus. What are they called? Just parasitic fungus? There's not a great name for them?
No, parasitic fungus.
But the ones so they live in the soil. No one likes them. They're considered jerks, like you said. The ones that everybody likes are the mutualists or the saprophytes, which eat decaying matter. And then sometimes they eat one another, and all this stuff, just I don't want to say the point of it, because who knows if there even is a point. But if there is a point, it is that that nutrients that get used by living things and locked into the living things when they die get unlocked so that other things can use them.
All right, so do you want to talk about the nitrogen cycle?
Yeah, because that's another thing that can get locked and unlocked thanks to these organisms and their symbiosis. Nitrogen is extremely important to plants. They use it to make chlorophyll. They use it to make some of their proteins and structures. But it's super abundant in the atmosphere, in the air. But not all plants are really good at unlocking it.
Not many, actually.
Which is right. Which is why you need some plants called nitrogen fixers to come along. And I think legumes are a really good example of this, in like alfalfa, peanuts, those things. And they can take it out of the air and turn it into a usable form. And they actually do that, I saw, not on their own accord. They have to become infected by a bacteria called rhizobium. And it's actually the infection from rhizobium that alters the plant to make it so that it can take nitrogen out of the air and deposit it in its roots for storage.
Yeah, most plants can't do that. They have to draw it from the soil around them.
Right.
And, we mentioned the balance in nature that we always are seeking, that homeostasis. What you would like is a balance between these nitrogen fixers and dead plants adding nitrogen into the soil, and then also those plants that are drawing that soil out. Like you want that all to sort of balance out together.
Right, exactly. And again, it's because there's help from bacteria helping fix nitrogen and nodules on the roots that other plants can come along and use in a or what's called a fixed form. So it's fixed nitrogen. Like you can have, say, a glass of seawater and you're really thirsty, but you can't drink it because it's not in a usable form, even though it's still water. But if you run it through a reverse osmosis filter and desalinate it, now it's usable water. So you can think of nitrogen fixing as like the Earth's version of reverse osmosis for nitrogen, converting it into a usable form for plants. The thing is we kind of talked about it before, and you just hit upon it. There's like a natural cycle, a natural process to all this, which things like agriculture especially has really kind of disrupted. And even after the research that's been produced over time, we're either being like willfully ignorant or still figuring it out, or people are still trying to get the word out. I don't know what the issue is. If it's just too expensive to do it right, I don't know. I'll have to go back and listen to our permaculture episode again. But one of the ways, like you said, that we disrupt this natural cycle, or the nitrogen cycle in particular, is by not planting things like cover plants that are nitrogen fixers to replenish the soil. Instead, we use factory-made fertilizer, which is just fixed nitrogen itself, to replenish the soil, which is much harsher and can have all sorts of cascading negative effects on the surrounding environment as well.
Yeah, because if you're doing a major agriculture job and you're pulling that nitrogen out, you've got to just artificially put it back in, and that's all fertilizer is.
Right.
Is you're feeding that manure or whatever fertilizer you're using. Manure has a lot of nitrogen, so that's why it's used as a fertilizer, but you're just pumping it back into the soil. There's a great documentary that's called, I think, Big Little Farm, maybe?
I've not heard of that one.
About this couple who, dropped out and started their own farm, but started a farm that they wanted to do right and to be in balance, like naturally, with itself. It's really good and daunting and inspiring all at once.
It's cool. It sounds a bit like the movie All of Me, where Lily Tomlin takes over Steve Martin's body, and they have to learn to coexist together kind of harmoniously. And I think they do at the end, if I remember correctly.
It's not Big Little Farm. The biggest little farm is what it is.
In Texas.
No, that's a Burt Reynolds movie.
Right. Oh, okay. And you said this is a documentary.
Yeah, Biggest Little Farm. It's really good. You should check it out. People.
Okay. Well, people should check out All of Me, too, if you ask me. The thing is, Chuck, is when you're talking about nitrogen fixing and say, like, okay, well, farmers should just grow alfalfa, and then whatever, say if you harvest corn or something like that, you till it into the grass, whatever's left over after you've harvested the corn, you till it into the ground, and that buried stuff actually provides a lot of food for all of those microbial life and earthworms and all that stuff. So they actually leave the roots of your plants alone. That's great. But even doing that requires more care than you would think, because if we go back to humus, remember, humus is a really great way to lock in carbon for hundreds or thousands of years. But we're finding that it can be fairly easily disturbed by agricultural practices like tilling. And that once you disturb it, all of a sudden it's like, oh yeah, well, I'm done. I'm out. If you're not going to appreciate me, I'm not going to hold on to your carbon anymore. And it starts to release it. So we're finding that agricultural practices like tilling are actually having a contribution and an impact to climate change as well.
Yeah, and it's not, and I think this came from the same interview with the assistant professor. She's saying it's not like it's the same as the burning of fossil fuels. There was an estimate is that soils have lost 120 PG. What does that stand for? Petagrams?
Yeah.
Petagrams of carbon since the dawn of agriculture, basically. And that since 1751, fossil fuel burning has had a cumulative total over 400 petagrams. So it's not on par, but it is, something to think about. And especially when you're talking about permafrost. And, that's why we talk about when climate change is sort of like this vicious cycle where things are heating up and then ice caps are melting, and when that stuff melts, that's releasing this permafrost soil that has been stored carbon for thousands and thousands of years,
right,
all of a sudden released back up into the atmosphere.
Yeah. And, because humus is most stable as a carbon sink when it's cold. So if it's so cold that it's been frozen for years, it's very stable. But yeah, as climate change warms it up, that starts to get released. And that is a problem. I mean, yes, 120 petagrams over the last 10,000 years. It doesn't seem like much, but we're getting to the point now where every little bit counts. And I think as part of the Paris Climate Agreement, you can count your carbon sinks, like the kind of soil you have, against your output to show whatever reduction you're working on. So it does count. It is taken into account. It's just nothing like fossil fuels, but it is an important component, it seems like.
Yeah, so basically, that's what they did in Biggest Little Farm, is get back to basics of the dawn of agriculture when they practice really sound soil management for the most part. Tilling, only what needs to be tilled. Don't go super deep or super wide if you don't need to. That ground cover that you were talking about shades that soil. And don't burn, and this is one of the big problems with big ag, is burning plant waste.
Yeah.
You don't want to do that. You want to bury that stuff and put it back into the earth.
Yep. Put it back into the earth, everybody, because the life down there wants it.
That's right.
That's the slogan for this one, okay?
Agreed.
So get out there and get your hands dirty and go feel the soil, and remember to say thank you, humus, as you let it move through your fingers, okay? Yes. Okay, everybody. And in the meantime, I think, Chuck, it's listener mail.
Yeah, this is from a teacher, I think.
Mm-hmm.
Is this a teacher?
I don't know.
Yes.
Okay.
Biology teacher, appropriately.
Nice.
Hey, guys, just listened to the episode on narcolepsy. Thought it would help clear up a confusion about the difference between a disease and a disorder. As a high school biology teacher, I had to explain the difference every year. The difference is subtle, but there is a simple way to remember. A disease is caused by a pathogen like a virus or a bacteria. A disorder is a malfunction due to genetics, trauma, chemical toxicity, or other non-living factor. Nice. The lines can become blurred a bit because the disorder can be triggered by a disease. Some cancers are triggered by viruses. Maybe a clearer example is HIV/AIDS. A person can be HIV positive, and if the viral disease is discovered in time and treated, they may never succumb to the disorder that is AIDS, which sets in when the infected person's immune system has been effectively eliminated. Hope this helps the issue. Thanks again. Keep up the good work. And that is from Rich Brusk from Manhattan, Kansas.
That's a Manhattan, Kansas.
That's right.
That is a world-class biology teacher, Chuck.
Totally.
What was his last name?
Brusk.
With a B?
Sure.
Thanks, Mr. Brusk from Manhattan, Kansas. We appreciate that, and we appreciate you being a biology teacher and a world-class one at that. If you want to show off what a world-class person you are, you can get in touch with us too, like Mr. Brusk did. You can send us an email. Send it off to stuffpodcast@iheartradio.com.
Stuff You Should Know is a production of iHeartRadio's How Stuff Works. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.
You know, you could be adored by everyone and still completely ignored by your cat. Trust me, I know. But if you feed your cat Sheba, you can go from being ignored to truly adored in 12 days, guaranteed, or your money back. Sheba has a full menu of products, appetizers, entrees, treats, even a kitten's menu. It's so cute, so Sheba has a product for even the pickiest eater. Like Sheba Puree, it's made with bone broth, their chef-inspired flavors. It's got a smooth and creamy texture that cats love and contains no corn, wheat, soy, or artificial flavors. It's food that your cat's gonna love. To learn more, check out Sheba.com. That's SHEBA.com.
Introducing the all-new Mazda CX-5, featuring more connection.
Hey Google, where's the nearest Pilates class?
Safety that has your back. More discovery on the scenic routes. More passion in the details. And more control in changing weather. The all-new Mazda CX-5. More to move every side of you. See it in 5 films at MazdaUSA.com/5sides.
Google is a trademark of Google LLC. Sequences shortened and simulated.
This is an iHeart podcast. Guaranteed Human.